For wood, consider using square drive screws. These screws feature a square recess that accepts a square head screwdriver, offering a secure hold and preventing cam out, which is stripping. Robertson, also known as square head screws, are similar to square drive screws, but with a more pronounced square head. They provide excellent torque and prevent slipping. Torx drive screws are another option. These screws have a star-shaped recess that requires a Torx screwdriver. They provide high torque and grip, making them ideal for tough materials. When dealing with metal, plastic, and drywall, hex head self-tapping screws are useful. These screws have a hexagonal head and a self-tapping thread that creates its own threads in thin materials. They come in various materials and coatings for different applications. Phillips head self-drilling screws are similar to hex head self-tapping screws, but with a Phillips head. They can penetrate hard materials without the need for pre-drilling. Drywall screws are specifically designed for use with drywall. These screws have a fine thread and a tapered head that allows them to countersink flush into the material. For one-handed use, an impact driver with a magnetic bit can be very helpful. Impact drivers provide high torque and can be paired with magnetic bits that hold screws securely. This allows for one-handed operation when fastening in tight spaces. A ratcheting screwdriver is another option. Ratcheting screwdrivers allow you to drive screws without constantly repositioning your hand. They come with various attachments, including magnetic bits. Other considerations include the material of the screw. Different materials provide different levels of strength and corrosion resistance. Common materials include stainless steel, hardened steel, and carbon steel. The length of the screw is important. Choose screws that are long enough to penetrate the material securely, but not so long that they protrude through the other side. Some screws come with a coating to prevent corrosion or increase lubricity. Choose a coating that is appropriate for the environment and application. When selecting screws, there are a few key features to consider. Firstly, the screw head type is a critical factor. Different head types, such as flat, round, or oval, are designed for specific applications and aesthetics. Flat head screws are often used when a flush finish is desired, while round head screws provide a more decorative appearance. Oval head screws offer a compromise between the two. Secondly, the thread type plays a significant role in the screw's performance. Coarse threads are typically used for softer materials like wood, as they provide greater holding power. Fine threads, on the other hand, are better suited for harder materials like metal, as they offer a more precise and secure grip. The screw's material is another important consideration. Stainless steel screws are highly resistant to corrosion, making them ideal for outdoor or marine applications. Brass screws offer good conductivity and are often used in electrical applications. Steel screws provide high strength and are suitable for a wide range of general-purpose applications. The drive type, which refers to the type of recess on the screw head, also affects the ease of use and torque that can be applied. Phillips head screws are commonly used, but they are prone to cam out, which is when the screwdriver slips out of the recess. Square drive screws, also known as Robertson screws, offer better resistance to cam out and provide a more secure grip. Torx screws, with their star-shaped recess, provide even greater torque and are often used in demanding applications. Hex head screws, also known as Allen screws, are typically used in machine applications and offer a high level of strength and precision. The length of the screw should be carefully chosen based on the thickness of the materials being joined. The screw should be long enough to penetrate both materials securely, but not so long that it protrudes excessively on the other side. As a general rule, the screw should penetrate at least half the thickness of the bottom material. The diameter of the screw is also an important factor to consider. Thicker screws provide greater strength and holding power, but they may also require larger pilot holes. Thinner screws are easier to drive and may be less likely to split the material, but they may not provide as much holding power. The point type of the screw affects its ability to penetrate the material. Sharp-pointed screws are ideal for self-starting and require minimal pre-drilling. Blunt-pointed screws are less likely to split the material, but they may require a pilot hole. Self-drilling screws have a drill bit-like point that allows them to drill their own pilot hole, making them ideal for use in metal or other hard materials. The finish of the screw can also affect its performance and appearance. Zinc-plated screws offer good corrosion resistance and are suitable for general-purpose applications. Black oxide screws provide a matte finish and are often used in applications where aesthetics are important. Chrome-plated screws offer a bright, shiny finish and are often used in decorative applications. When working with electrical boxes and panels, it's important to choose screws that are specifically designed for electrical applications. These screws typically have features such as a grounding screw that allows for secure grounding of the electrical box or panel. They may also have features such as a tamper-resistant head that prevents unauthorized access to the electrical components. In addition to selecting the right type of screw, it's also important to use the correct installation technique. Over-tightening screws can damage the material or strip the threads, while under-tightening screws can result in a loose or unstable connection. It's important to use a screwdriver or drill with the appropriate torque setting to ensure that the screws are tightened to the correct level. When working with wood, it's often helpful to pre-drill a pilot hole before driving the screw. This can help to prevent the wood from splitting and make it easier to drive the screw straight. The size of the pilot hole should be slightly smaller than the diameter of the screw. When working with metal, it's important to use a lubricant to reduce friction and prevent the screw from seizing. A common lubricant is cutting oil, but other lubricants such as grease or wax can also be used. When working with drywall, it's important to use drywall screws that are specifically designed for this application. Drywall screws have a special head that is designed to countersink into the drywall without tearing the paper. They also have a fine thread that provides good holding power in the drywall. When installing electrical boxes and panels, it's important to follow all applicable electrical codes and safety regulations. This includes ensuring that the electrical box or panel is properly grounded and that all wiring connections are made correctly. It's also important to wear appropriate personal protective equipment, such as safety glasses and gloves, to protect yourself from electrical hazards. Choosing the right type of screw is essential for ensuring a secure and reliable connection. By considering the factors discussed above, you can select the screws that are best suited for your specific application. Remember to always follow safety precautions and consult with a qualified electrician if you have any questions or concerns. When choosing screws, also consider the environment in which they will be used. If the screws will be exposed to moisture or corrosive substances, it's important to choose screws that are made from corrosion-resistant materials such as stainless steel or brass. If the screws will be used in a high-temperature environment, it's important to choose screws that are made from heat-resistant materials such as high-temperature alloys. The type of tool used to drive the screw can also affect the choice of screw. For example, if you are using a power drill, it's important to choose screws that are compatible with the drill's drive system. If you are using a manual screwdriver, it's important to choose screws that are easy to grip and turn. The quantity of screws needed for the project is also a consideration. If you are installing a large number of screws, it may be more cost-effective to purchase screws in bulk. If you are only installing a few screws, it may be more convenient to purchase screws individually. When purchasing screws, it's important to choose screws that are of high quality. Low-quality screws may be made from inferior materials or may have manufacturing defects that can compromise their performance. It's also important to choose screws that are from a reputable manufacturer. Reputable manufacturers typically have quality control processes in place to ensure that their screws meet industry standards. Before installing screws, it's important to inspect them for any defects. If you find any defective screws, do not use them. Discard them properly. When installing screws, it's important to use the correct technique. Over-tightening screws can damage the material or strip the threads. Under-tightening screws can result in a loose or unstable connection. It's important to use a screwdriver or drill with the appropriate torque setting to ensure that the screws are tightened to the correct level. After installing screws, it's important to inspect them to ensure that they are properly installed. Make sure that the screw heads are flush with the surface of the material and that the screws are not loose or damaged. If you find any problems with the screws, correct them immediately. In addition to the above considerations, it's also important to be aware of any applicable built-in codes or regulations that may govern the use of screws in electrical applications. These codes and regulations may specify the type of screws that must be used, the spacing of the screws, and the installation techniques that must be followed. It's important to consult with a qualified electrician or building inspector to ensure that you are complying with all applicable codes and regulations. The National Electrical Code, or NEC, provides guidelines for electrical installations, including the selection and installation of screws. While the NEC doesn't explicitly list specific screw types for every application, it emphasizes the importance of using hardware that is listed and labeled for its intended purpose. This means that the screws should be suitable for the environment, the materials being joined, and the electrical load they may be exposed to. For example, when grounding electrical boxes, the NEC requires the use of listed grounding screws that are specifically designed to provide a reliable electrical connection. These screws are typically made of corrosion-resistant materials and have a unique design that ensures a tight and secure connection to the grounding conductor. When securing electrical panels to walls or other surfaces, the NEC requires the use of fasteners that are strong enough to support the weight of the panel and withstand any vibrations or stresses that may occur. The specific type of fastener will depend on the construction of the wall or surface, but common options include lag screws, toggle bolts, and expansion anchors. It's important to consult with a qualified electrician or building inspector to determine the appropriate fasteners for your specific application. The NEC also addresses the use of screws in wet or damp locations. In these environments, it's important to use screws that are made from corrosion-resistant materials such as stainless steel or brass. The NEC may also require the use of special sealing washers or gaskets to prevent moisture from entering the electrical enclosure. When working with electrical equipment, it's essential to follow all applicable safety precautions. This includes disconnecting the power supply before working on any electrical components and wearing appropriate personal protective equipment, such as safety glasses and gloves. It's also important to use insulated tools to prevent electrical shock. If you are not comfortable working with electrical equipment, it's best to consult with a qualified electrician. Working with electricity can be dangerous, and it's important to take all necessary precautions to protect yourself and others. The type of screw can also affect the amount of force required to drive it. Some screws are designed to be driven with a lower amount of force, while others require a higher amount of force. It's important to choose screws that are appropriate for the tools that you are using and the materials that you are working with. Some screws are designed to be self-tapping, which means that they can create their own threads as they are being driven into the material. Self-tapping screws are often used in applications where it is difficult or impossible to pre-drill a pilot hole. Other screws require a pilot hole to be drilled before they can be driven into the material. The size of the pilot hole should be slightly smaller than the diameter of the screw. The type of screw can also affect the appearance of the finished product. Some screws are designed to be countersunk, which means that the head of the screw is flush with the surface of the material. Other screws are designed to have a decorative head that is visible on the surface of the material. The type of screw can also affect the ease of disassembly. Some screws are designed to be easily removed, while others are designed to be more difficult to remove. The ease of disassembly may be an important consideration in applications where the product may need to be disassembled for maintenance or repair. When choosing screws, it's important to consider all of the factors discussed above and to select the screws that are best suited for your specific application. If you are unsure of which type of screw to use, it's best to consult with a qualified professional.